There is a weapon that was designed specifically to kill aircraft carriers, not to damage them, not to mission kill them temporarily or force a retreat, to kill them, to send a 100,000-ton nuclear-powered warship and its crew of 5,000 to the bottom of the Pacific Ocean with a single warhead delivered at hypersonic speed from a range that places the launch platform entirely beyond the reach of any carrier-based aircraft. It is called the DF-21D. Its NATO designation is CSS-5 Mod 5. The Chinese call it the carrier killer, and its existence, its deployment in hardened mobile launchers along China's eastern coastline, and its integration into a targeting architecture that combines satellite surveillance, over-the-horizon radar, and unmanned aerial vehicles into a single kill chain, represents the most significant doctrinal challenge to American carrier-based power projection in the history of naval aviation. The question that every Pacific Fleet commander has to answer is not whether the DF-21D exists. It exists. The question is whether the kill chain that makes it lethal can be disrupted, degraded, or denied at the precise moment it matters most. And the answer to that question, the real answer, tested not in simulations, but in the actual operational environment of the Western Pacific, determines whether American carrier aviation remains viable in the first island chain, or whether Beijing has successfully created a zone of denial that reshapes the strategic balance of the Indo-Pacific. On a Wednesday morning, the time was 6:22 local. The Philippine Sea was running with a moderate northeast swell, the sky in transition from the deep black of pre-dawn to the first gray of civil twilight. A United States Navy carrier strike group was operating approximately 340 nautical miles east of the Philippine coastline, conducting a scheduled Indo-Pacific deployment transit that would bring the group through the Philippine Sea and into the South China Sea within the next 48 hours. The transit route was deliberate, a freedom of navigation declaration by movement, the kind of operational presence that communicates intent more clearly than any diplomatic statement. 340 miles east of the Philippines placed the strike group inside what Chinese military doctrine designated as the first island chain defense zone, not inside Chinese territorial waters, not remotely close to them, but inside the engagement envelope of the DF-21D, whose maximum range of approximately 2,000 kilometers extended well beyond the first island chain and into the Philippine Sea itself. The strike group's commanders knew this. They had known it since the operation order was written. Operating inside the DF-21D's range was not a miscalculation. It was the point. In the Combat Information Center, the morning watch had been running the standard pre-dawn readiness cycle when the intelligence update arrived at 6:09. The update came from a combination of sources, signals intelligence collected by an EP-3E Ares, 2 operating in international airspace north of the Philippine Islands, satellite imagery tasked against a known DF-21D brigade deployment site on China's Fujian coast, and airborne electronic intelligence from an RC-135V rivet joint that had been conducting a collection mission in the area for the past 6 hours. The 3 sources analyzed together produced a picture that the watch officer absorbed with complete seriousness. The DF-21D brigade at the Fujian site had gone active. Active meant that the brigade's mobile launchers, truck-mounted, capable of rapid repositioning, designed to complicate targeting by being in a different location every few hours, had conducted a movement from their garrison positions to what the satellite imagery assessed as prepared firing sites. It meant that the brigade's supporting radar and command systems were radiating on frequencies consistent with targeting operations. It meant that the integrated surveillance network that the DF-21D depends on, the constellation of satellites, the OTH radar systems, the maritime patrol aircraft that provide the real-time targeting data without which a ballistic missile cannot hit a moving ship at sea, was being exercised in a mode that was more than routine training. The watch officer reached for his headset at 6:17. Captain, CIC. Intelligence update on DF-21. D-Brigade activity, Fujian site. Request your presence. The captain arrived in 4 minutes. He read the intelligence summary on the display, asked 3 precise questions about the confidence levels behind each source, received 3 precise answers, and then stood at the tactical picture for a long measuring moment. 340 miles. The DF-21D's kill chain required multiple steps to function: detection, tracking, targeting data relay, launch authorization, terminal guidance. Each step in that chain was a vulnerability. Each step represented a moment where the chain could be broken, where the information flowing through it could be degraded, where the sensor giving the missile its final guidance update could be denied or deceived. The DF-21D itself, once launched, was extremely difficult to intercept. But a missile that cannot find its target is not a weapon. It is an expensive piece of falling hardware. "All right," the captain said. "Let's talk about the kill chain." What followed was a 12-minute briefing by the strike group's electronic warfare officer, a commander who had spent 18 months at Pacific Fleet studying Chinese anti-access and area denial architecture before taking this assignment. She walked through the kill chain systematically: the surveillance layer, the over-the-horizon targeting radar, the Type 670 maritime patrol aircraft that provided the terminal phase targeting update, the data relay systems. She identified for each layer what the strike group had available to contest it. The briefing was not reassuring in the sense of minimizing the threat. It was reassuring in the sense that it demonstrated that the threat had been studied with the same thoroughness that the Chinese had applied to developing it, and that the contest between the kill chain and the systems designed to break it was genuinely competitive. At 6:41, the picture developed further. The RC-135V reported that the OTHB radar system associated with the Fujian Brigade had shifted its search pattern. The beam orientation had moved in a way consistent with the radar searching for a target in the Philippine Sea. The radar's sweep pattern, analyzed against the known characteristics of Chinese OTH systems, was consistent with an attempt to localize a surface group at approximately the range and bearing where the carrier's strike group was currently operating. They were looking for the carrier. The captain made his first active decision at 6:44. Electronic warfare officer, I want active emissions control across the entire group. Minimum radar output. Every ship that can reduce its radar cross-section contribution without compromising the inner air defense picture does so now. I want us to be as quiet electronically as we can be while still maintaining the defensive capability we need. This was the first layer of the response. Not counterattack, not dramatic action, but the disciplined management of the strike group's own electronic signature. The OTH radar was looking for them. The less they broadcast, the harder that search became. Every ship in the strike group that reduced its active radar emissions made the job of the Chinese targeting system marginally harder. Individually, the effect was small. Collectively, across a strike group of 6 major combatants plus logistics ships, the aggregate reduction in the electronic signature was meaningful. At 6:51, the EA-18G Growlers were launched. 2 aircraft, their ALQ-99 jamming pods, configured for the specific frequency bands used by Chinese OTH radar systems and Type 670 aircraft targeting datalinks. They climbed to altitude and assumed jamming orbits calculated to place their radiated interference between the Chinese targeting systems and the strike group's position. Not a blanket jam, which would be detectable and geolocatable, but a structured, directional interference pattern designed to introduce noise and uncertainty into the targeting picture without revealing the exact nature or source of the interference. This was the second layer, not silence, directed confusion. The Chinese targeting system was still operating, but the quality of its picture was degrading. The confidence of the data flowing through the kill chain was declining. And a ballistic missile targeting a ship at sea requires extremely high confidence, continuously updated targeting data to achieve a hit. Uncertainty is the adversary's enemy, not just the defender's. Silence is a signal, and the signal the EA-18Gs were sending was precise, professional, and calibrated. At 7:03, the maritime surveillance picture added a new element. A Type 670 Chinese maritime patrol aircraft operating from a base on the Fujian coast was detected by the E-2D Hawkeye at a range of approximately 310 miles, bearing 280, course southeast at 6,000 meters. The Type 670 was the eyes of the kill chain, the airborne platform that would provide the real-time targeting update to the DF-21D in its terminal phase, the platform without which a moving ship target could not be reliably struck. The E-2D locked the contact immediately and fed its position to the strike group's air warfare coordinator. "Captain, we have the targeting aircraft," the air warfare coordinator reported. 3 words that changed the operational calculus completely. The kill chain had a visible, trackable node, and that node was 310 miles away, inbound, doing exactly what a Type 670 does when a DF-21D brigade is on a targeting mission. The captain looked at the contact icon on the display. "Track it. Don't touch it yet. It's in international airspace. What's its projected CPA to our position? At current course and speed, it will pass within approximately 200 miles of our current position in approximately 41 minutes, sir. That's inside its targeting datalink range. Inside targeting datalink range. Within 41 minutes, the Type 670 would be close enough to relay continuous targeting updates to the DF-21D brigade. The kill chain would be complete." "What do we have available for an intercept?" 2 FA-18Fs on Alert 5, sir. Alert 15 is in the ready room. The E-2D has the contact locked. Bring the Alert 5 to engines turning. Hold the launch. He turned to the electronic warfare officer. When that aircraft reaches 250 miles, I want the Growlers to shift their jamming priority to the Type 670 datalink frequencies. Specifically, I want his targeting relay disrupted at the moment he thinks he's in range. The geometry tightens, even across 300 miles of open Pacific. At 7:19, the Alert F/A-18Fs launched. They climbed northwest at maximum military power, guided by the E-2D toward an intercept position that would put them alongside the Type 670 at a distance of approximately 1 mile. Close enough to be unambiguous, far enough to be non-threatening in a legal sense. The intercept geometry was calculated to place the American aircraft in the Type 670's visual and radar scan before the Chinese aircraft reached its intended operating position. At 7:24, the EA-18Gs shifted their jamming pattern to the Type 670's targeting datalink frequencies. The shift was precise and surgical. The EA-18G crews had been given the specific frequency parameters by the RC-135V's collection, which had spent 6 hours cataloging every emission from the Chinese targeting network. The jamming was not a blunt instrument. It was a scalpel applied to the specific frequencies that carried the specific data that the kill chain needed to function. The Type 670's crew, monitoring their own systems, would have seen their data link performance degrade. They would have known their targeting relay was being interfered with. They would not necessarily have known immediately where the interference was coming from. At 7:31, the two Super Hornets achieved visual contact with the Type 670 at approximately 1.5 miles. The intercept was clean. The FA-18Fs had appeared alongside the Chinese aircraft precisely on the geometry the E-2D had projected. The Type 670's crew was looking at 2 American fighter aircraft, 1 mile off each wingtip, flying in a professional escort formation that communicated everything without saying a word simultaneously on the military aviation emergency frequency. The carrier's communications officer transmitted: Chinese military aircraft bearing 280, you have been intercepted by United States Naval Aviation. You are operating in the vicinity of United States Navy forces in international airspace. Your targeting data link systems are experiencing interference. All your emissions and positions have been tracked and recorded. We recommend you alter course and exit this area. The transmission was precise. Every word documented, every word true. At 7:34, 3 significant things happened within 90 seconds of each other. The Type 670 began a left turn, banking away from the carrier's bearing, course shifting from southeast to north-northeast. The OTH radar in Fujian shifted its search pattern back toward a neutral orientation away from the Philippine Sea bearing, where it had been focused for the past 53 minutes. And the signals intelligence from the RC-135V showed a sharp reduction in the data traffic flowing between the DF2 1D Brigade's command systems and the targeting network, a reduction consistent with a stand-down of the active targeting cycle. The kill chain had been broken, not by destroying any of its components. Not one Chinese asset had been touched. Not one emission had been jammed in a way that constituted hostile action under any legal framework. Not one weapon had been pointed. The kill chain had been broken by denying it the information quality it needed to function, by making the targeting picture uncertain, by placing an intercept aircraft next to the eyes of the kill chain at the precise moment those eyes needed to be working clearly. In the CIC, the watch team logged the Type 670's course reversal, the OTH radar reorientation, and the reduction in brigade data traffic in the same professional tone they had used throughout the entire event. The captain watched the contact icons migrate away from the strike group's position for 4 minutes before he spoke. Reconstruct the entire event. I want a timeline from the initial intelligence update at 0609 to the Type 670 departure. Every jamming employment, every intercept vector, every intelligence source, every emission change logged with timestamp. Package for Pacific Fleet and Indo-Pacific Command within 2 hours. He looked at the electronic warfare officer. Your jamming geometry was exactly right. Log the specific frequency parameters used against the datalink. I want that in the classified annex. He looked at the air warfare coordinator. The E-2D intercept geometry was perfect. Tell the crew he left the CIC at 7:49. The carrier strike group resumed its standard transit posture. The Philippine Sea was fully lit now, the sun above the horizon, the swell catching the early light and breaking it into the particular flat brilliance of a Pacific morning. The transit toward the South China Sea would continue as scheduled. The freedom of navigation declaration that movement represented had not been interrupted, had not been diverted, had not flinched. What had occurred in those 93 minutes was the operational answer to the strategic question that the DF-21D poses to American naval power. Yes, the weapon exists. Yes, its range covers the first island chain. Yes, its kill chain, when fully functional, represents a genuine threat. But a kill chain is not a weapon. It is a system, and systems have vulnerabilities, nodes that can be disrupted, data flows that can be degraded, sensors that can be confused. The United States Navy has spent years studying those vulnerabilities with the same systematic rigor that China applied to building the kill chain in the first place. The result on this Wednesday morning in the Philippine Sea was a demonstration that the carrier killer has to first find the carrier, then track the carrier, then relay that track with sufficient precision and confidence to guide a hypersonic warhead to a moving target. And between the finding and the hitting, there are steps. And between those steps, there are people and systems and doctrine and the accumulated professional competence of a naval force that has been thinking about this problem for longer than the DF-21D has existed. Modern power projection in the Western Pacific is not about ignoring the DF-21D. It is about understanding it well enough to operate within its envelope with confidence. The confidence that comes from knowing the kill chain, knowing its vulnerabilities, and having trained the crews and built the systems to exploit those vulnerabilities precisely, proportionately, and completely. The Philippine Sea is not a no-go zone. The first island chain is not a wall. It is a contested space. And on this morning, the contest had gone exactly as the professionals on both sides of it understood it would go, when one side brought complete knowledge and complete preparation to the encounter. The carrier continued west. The kill chain was quiet. The Pacific held its light,